All right, the last thing that we're going to be doing today, and I didn't write this down in my notes, is, well, I did, but not that. Anyway, is the last video is real world applications. Okay, so we're just going to do a problem from the book. It's 46. You have to do 45 and 47. They're pretty similar. Okay, so we have a circumference, and we can write the circumference as a function. And remember, this is not c times r. This is just like f of x. F is the function, x is the input. C is the function here, and r is the input. So this is circumference as a function of the radius. C of r is equal to 2 pi r. So what it wants us to do is express the radius as a function of its circumference. So instead of c is equal to stuff with r, we're going to write r is equal to stuff with c. All right, so again, this is not r times c, this is r of c, just like we write f of x. Okay, let's start with that. Okay, so c of r is equal to 2 pi r. And again, just like, remember before, right? We started with f of x is equal to, something with x's. To find the inverse function here, right? We switched the x's and the y's, but there is no y here. So we're not going to, right? We wrote this with y's instead. We said, I don't want to worry about function notation. We do the same thing here. Let's not write this in function notation. Let's just write this with variables. So it's the same first step that we've been doing in earlier videos in video 2. So don't get thrown off by this function notation right here. Okay? And now again, to find the inverse function, we'd switch the c and the r's, switch the x's and the y's. But in this case, right, what is it asking? It wants us to find r as a function of c. It really just wants us to skip the switching step and just solve for r. They're both equivalent methods. So if we solve for r, we divide both sides by 2 pi. And we're going to get c over 2 pi is equal to r. And again, just like in that other one, we would end up with y is equal to x minus 5 as our inverse function. Now we go back to writing it in function notation. So it said, call this function r of c. So the function r of c is you take the circumference and you divide it by 2 pi. This is function notation. Remember, this is r of c. This is not multiplication, even though we write it the same exact way that we would write multiplication. So that's our first part of our answer. This is our inverse function. Okay? Moving on. So we found r of c. This says find r of 36 pi and interpret its meaning. So r of 36 pi. Oh, okay. This is like f of 2. R of 36 pi. It's, okay, take this function that we found, evaluate it when c is 36 pi. So replace the c with 36 pi, and let's see what it simplifies to. Well, the pi's are going to cancel. 36 divided by 2 is 18. So notice, right, that when c is 36 pi, r is 18. So the interpretation here is when the circumference of a circle is 36 pi units, its radius, r, is 18 units. So that's all it's asking you to do. Hopefully you don't write it behind somebody's head like I just did to you guys. All right. C is our input now for this inverse function, and c is 36 pi. R is the output, and the output is 18. The radius is 18 when the circumference is 36 pi. All right, and that's what you do for these applications. Finally, a short video. If you have more questions about this, feel free to let me know though, okay?